Hi guys, in this specific video we're going to do one of the application problem set of hyperbolic functions, and this basically is going to entail the conversion of this specific representation into the complex analogies that we had mentioned earlier in our first video, and thereafter we're going to look for the value of x in this specific case. So this is a quotient 5 minus the sinh x, 5 the sinh x minus 5 is equals to 0. And of course, I'm going to show a step-by-step evaluation of this specific hyperbolic function and try to see how we can be able to find the values of the unknown, which is x in this particular case. So first, we had given different identities. In our previous video, I had mentioned that we can be able to represent this hyperbolic function using different identities. And so for that, one of them, of course, I had mentioned was the quotient of x. And of course, the given various representations of these specific functions. So for instance, I mentioned that the quotient of x is going to be represented as a half into ex plus e minus x given as such. And those are going to be exponents in that particular case. And I mentioned that the sinh of x is going to be represented using a complex analogy of x minus ex. So this is going to be negative x given as such. And of course, these are going to assist us in doing, or rather making this particular evaluation convenient. So as we go by, I'd like to request our members to kindly remember those specific conversions that we're going to do. So in this particular case, I'm going to have this one given as such. So therefore, we're going to try and do an evaluation of this specific hyperbolic function. So, so the first step that we're going to do is to try and convert these specific representations into complex numbers, which we said the quotient of x is going to be given as ex plus e raised to negative x given as such, and this is going to be minus 5 into, this one was given as a half, so this is going to be given as this particular coefficient is going to represent the whole of this, so it's going to be a half ex minus e negative x. So these ones I'm mentioning for x are basically the exponents, so therefore this is going to be minus 5 is equivalent to 0 given as such. So we're going to perform this one as a normal evaluation of algebraic expressions. So therefore this is going to be giving us e over 2, this is going to be ex plus e negative x over 2 given as such, and this is going to be minus 5 over 2, and then this is going to have ex minus, so this is going to be minus, therefore it's going to give us a positive 5 over 2 e negative x, and then this is going to be minus 5 is equivalent to 0 given as such. So therefore in this particular case we're going to just remove this particular fraction, and this is going to be a multiplication by 2 in all these parts of the equation. So this is going to give us ex and then plus e negative x minus, so this is going to be 5 ex plus 5 e negative x minus 5 is equivalent to 0 given as such. And then we're going to see that we can be able to put like terms in this specific case. For instance, if I look at this and this, these are going to be like terms since they have the same term for ex. So therefore this is going to give us negative 4ex as our first term, and then we're going to have plus, so this is e negative x and this is e negative x. So this one and this one are the like terms. Therefore you're going to be giving us a coefficient of 6 e negative x given as such, and then we're going to have the last one. As I said, it's going to be multiplied by 2, so this is going to make 10. As we said, this is going to be multiplied by 2 of course across the equation, and this is going to give us this specific result. So therefore we're going to have this one represented as 10 given as such. We can be able to do a rearrangement of this specific equation for it to give us 6e negative x minus 4 ex minus 10 is equivalent to 0 given as such. So next we can be able to represent this one in terms of perhaps this negative ex represents a reciprocal of 1 over ex. So therefore we can be able to transform this last bit of the equation into a form over 6 over ex. So the reciprocal ex has changed from negative to positive in this specific order. So this is going to, of course, be 4 ex minus 10 is equivalent to 0 given as such. So in this particular case, I hope that we are trying to follow this specific procedure. Now for me, because I'm having a limited space, I'm going to pick it from this specific end and therefore proceed. So I'm going to do away with this. I hope that we have followed the procedure from this specific point, and then I'm going to have it represented as this. So I'm going to transfer this one into 6 ex minus 4 ex minus 10 is equivalent to 0. So I'm going to do away with this. So next from this, then therefore we're going to see that we can be able to just multiply every part of this specific equation by exponent, the natural log of e raised to x, and this is going to give us 6 minus 4e. So multiple of this one is going to give us the similar bases which are multiplied. So therefore we're going to multiply this specific exponent, and this is going to give me 4e to x minus 10ex is equivalent to 0 given as such. So therefore from this one we can be able still to do an evaluation of this, perhaps by still trying to just take this one to the other side. Still the value of that specific equation is going to be the same. So we're going to have 2x, and then this is going to be plus 10ex, and then this is going to be minus 6 is equivalent to 0. So this one I've just taken them to the other side, and this is going to maintain the value, only that I've just changed the numbers of the equal sign to get a positive representation for this specific equation. And therefore from this one we can be able to say let this complex part, which is e raised to power x, be represented as y. And therefore we can be able to perform an evaluation of 4y squared for the first one plus, and then this is going to be 10y minus 6 is equivalent to 0. So from this one we can be able to use the normal evaluation of a quadratic equation in order to find the value of that specific function. And in this case still we can be able to do simplification for us to obtain another function which is similar to this, of course a simplified version of this specific function by division over 2. So this one is going to be equivalent to 2y squared plus 5y minus 3 is equivalent to 0 given as such. And therefore from evaluation of this we can be able to find that we're going to find the factors of this specific equation as, of course, 2y minus 1, and then y plus 3 is equivalent to 0 given as such. So the factors for this are going to be 2y is equals to 1. So therefore the value for y is equivalent to a half, or so this for y plus 3 is equals to 0. This is the same as y is equals minus 3. So therefore the value for y is going to be either a half or minus 3 given as such. So we accept that e raised to x is going to be equivalent then therefore to a half or negative 3 given as such. And therefore from the evaluation of that one, we're going to find the value of e by trying to employ the concept of natural logarithms. Now from the laws of a logarithm, we can be able to represent this one using the natural log of e is equals the natural log of 0.5 for the first case. So I've just taken this exponent and involved the concept of logarithms. This is going to be a coefficient x, natural log of e is equivalent to natural log of 0.5 given as such. And then for the second one, still we are going to involve the concept of natural logarithms, whereby we are going to see that, so I'm going still to do away with this, where we're going to see that the ex is equivalent to negative 3. So implying that x, the natural logarithm over e is equivalent to the natural logarithm of negative 3 given as such, or negative 3, negative the natural log of 3 given as such. And this is going to give me the value of, you can do an evaluation and find the answer, and maybe if it's different from mine, we can be able to do that one, or maybe take a note in the comment section so that we can be able to do rectification. But I'm finding one of the values of x, which is going to be equivalent to negative 0.693. And of course, that's how we can be able to do an evaluation of a similar types of hyperbolic function. So from the first case, I've said that hyperbolic functions are the complex analogies of trigonometric functions, and this can be easily solved by expressing them in terms of exponentials rather than using their trigonometric analogies using the the base of the natural logarithm, which I've mentioned as Euler's number, which is e. And of course, through doing that substitution, it's going to involve the use of those, of course, complex analogies. So by substituting it with the quotient of x, the sign of x, and then trying to do it using the normal way of solving algebraic equations, and therefore that is going to give us a form of an equation which is going to be of this similar, of course, this particular kind, and then therefore we're going to involve the same way of trying to solve that to find the value of x. So in this particular case, we are going to come across a number of hyperbolic functions, and of course I'm going to use or employ different methods which I'm going to mention in those specific videos in trying to solve them. So I hope that we have understood this specific application, and we're going to do it appropriate in case we come across them. So check our description boxes for various links of other videos which are going to involve the aspect of complex numbers or hyperbolic geometry. So that is it for now, guys. By God bless you. Kindly subscribe to our channel and engage us in the comment section for more. That is it for now. Bye. God bless.